In this video, we're going to tackle the final task in part 1 of the exercise, the deterministic results. Before we jump into this, I'd like us to just recap what we've accomplished so far in the exercise over the previous 7 tasks. If you think back to task 1, in task 1, we were putting in the input parameters on the inputs sheet. So we had 3 different groups. We had the transition probabilities. So first of all, for treatment A, you then put in relative risk for treatment B, and that allowed us to calculate the transition probabilities for treatment B based on the probabilities for A and the relative risks. You then put in treatment costs for A and B. You put in other healthcare costs that varied by the state, and you put in health utilities that also varied by the state. You then put together the model sheet. So we constructed the transition matrix for treatment A based on those transition probabilities. You use these to calculate the sample path, which is the proportion of the cohort that's in each state in each cycle. And you use that to calculate the costs for the cohort as a whole in each cycle, in each state, and you aggregate it over them. So we have the aggregated costs for each cycle for treatment A. And then you did a similar thing for the QALYs for treatment A to get the aggregated QALYs for treatment A in each cycle. And then you did the whole thing again in task 3 for treatment B, the transition matrix, sample path, costs, and QALYs. Then we did some discounting. You calculated discount factors, and you used these discount factors to convert all of these aggregated costs for treatment A and treatment B and the aggregated QALYs for treatment A and B to present values. You discounted these, and these are all stored on the discounting sheet. And in this task, in task 8, we're going to be using some of these values. Some of these discounted costs and QALYs are going to be reported within your results table. And I just want to highlight, there's a couple of these cells here. If you click on the total discounted aggregated costs for treatment A, you can see that there's a name that's been assigned here. So R_costs_A. That's quite important, that cell. That is the total discounted aggregated cost for treatment A. And we've got the same thing going on for treatment B. In DX34, that's been given a name, R_costs_B. And then the same thing for the QALYs for A, the total QALYs for A are here, and the total QALYs for B are over here. That's been given the name R_QALYs_B, so results QALYs B. And then after doing the discounting, we calculated the incremental outputs. So what is the incremental cost of treatment B versus treatment A? And that was then aggregated. It was totaled over all of the cycles. And that's been assigned a name. We're going to use that within this task on our results sheet, R_incremental cost. And we did the same for the QALYs. So that's also called R_incremental QALY. We're going to use that in this task on the results sheet. You then calculated incremental net monetary benefit. We did that mini exercise on what is net health benefit, what's net monetary benefit. And you calculated the incremental net monetary benefit. And the total over all cycles has been summarized here as R_incremental net monetary benefit. And then finally, in the previous task, you calculated the cumulative incremental net monetary benefit for each of the possible time horizons from 1 cycle up to 60 cycles. So that's where we've got to. Let's now do task 8, the deterministic results. And a new sheet has now appeared called deterministic results, which I'll open here on the right. And you can see that there's a big table that we need to complete. There's also a graph, and this figure here it's ready for you, but you need to put in the data to go in the figure. And there's also another figure here, which we'll come to in a few moments, and we'll talk about how you would interpret that. So how are we going to do this summary of deterministic results table? And the way that this table is laid out is exactly how you'd see it in most academic papers. For each strategy here, for treatment A, treatment B, we report the costs. We would then report the incremental costs of the more expensive strategy. We report the QALYs and the incremental QALYs of the more expensive strategy. Then we could report, this is not always reported, but you can report the net monetary benefit for each strategy and the incremental net monetary benefit of the more expensive strategy. And then finally the ISA. So often these columns are not reported, but there's no harm in reporting them. So that's our first step. Step 8.1 is to construct this table. And as I just showed you, we've got some really important results from previous tasks that have had names assigned to those cells. Let's use those cells. So what is the cost? And we're using cost here as a shorthand for the total aggregated discounted costs for each treatment. So what are those costs for treatment A? And we're going to say equals, and we've got this assigned name. So R underscore costs A. So that is just pulling in the value from the discounting sheet there. And then we're going to do a similar thing for B. There we go. And for the incremental costs, we have a choice here. We could just do this minus this, or we can pull this in from the incremental costs sheet. So we will do both approaches. We're going to do, for the costs, we'll pull them in. So R underscore incremental costs. There we go. And then for the qualies, we will, first of all, we'll pull those in. So we need R underscore qualies A. And do you know what? I'm going to just save myself a couple of seconds by copying that. Oh. And here I'm going to paste it in and just change A to B. Okay, and if you recall, for the incremental costs, we just referenced the incremental cost sheet. We don't have to do that. We can just do equals the qualies for B minus the qualies for A. That will give us exactly the same number as we had on the incremental cost sheet. Oh, sorry, the incremental outcome sheet. Okay, now what do we do next? We need to do the net monetary benefit, and there's a paragraph here that I'll let you read. But just to be clear, the net monetary benefit for each strategy is not the incremental net monetary benefit that we calculated earlier. It's just the net monetary benefit for each treatment. So you can calculate that just by taking the qualies that are in column F, multiplying it by the threshold, and then subtracting the costs that are in column D. So let's just do that right now. Equals the qualies here, multiply by the threshold. So S underscore threshold, and then just subtract the costs here. And calculating the net monetary benefit for each strategy is really helpful if you have a model with lots and lots of different treatments, different strategies. Very often diagnostic tests might have multiple different cut points that you could use. You have a lot of different treatment strategies, diagnostic test strategies to compare. Calculating the net monetary benefit for each of them allows you to very, very quickly determine which strategy is the most cost effective. Much easier than using ICEs. I'm just going to take that and paste the formula, and what it's going to do is just move down to F22 and D22. So that's going to work just fine. And then we can take the incremental net monetary benefit, which has a named range assigned to it. So Inc net monetary benefit, there we go. We could also just do this minus this. You'll see that it's exactly the same number. And then finally, it's the ISA, which we've not previously calculated. We don't have a name assigned to that yet. So we would take the incremental costs, which are here, and divide it by the incremental qualies that are here. Okay, so that's step 8.1 complete. The NAs here, we don't need to fill in. So it's standard practice to just put an NA for the incremental costs, qualies, net monetary benefit, and ISA for the cheapest strategy. Because there is no incremental cost for A. We only calculate the incremental cost, the incremental quali, incremental net monetary benefit, and the ISA for the more expensive strategy B. So that's why these remain as NA. Okay, so that is step 8.2 completed. 8.1 completed. 8.2 is what we're starting now, and that is to plot the incremental cost effectiveness plane. So that's going to appear just here, but we need to fill in the data that we're going to plot on this. Now, when you have a deterministic comparison on the incremental cost effectiveness plane, there is just one point on that plane where that's going to be plotted, right? So the incremental cost, the incremental quality for the more expensive strategy. The comparator, in this case treatment A, is just plotted at the origin of this plane, so at 0, 0. Treatment B, we need to calculate these. So the first step is to put in the incremental cost of treatment B in I35. So that's going to be this value here. Okay, and then we need to pull in the incremental qualies. Okay, so that's going to be this one here, G22. Okay, so we now have a point on the plane here. And what we need to do next is to plot a cost effectiveness threshold across our incremental cost effectiveness plane. And the way to do that in a spreadsheet package like Google Sheets or Microsoft Excel is to just plot 2 points and put a line through them. And so any 2 points will do that lie on the line that the threshold passes through. And so you can see, I'll let you read this in your own time, but the first point that you could use is to just use the origin. So in cells I36 and J36, just put 0. So 0, 0 is a point on the plane that the threshold line will pass through by definition. And then we need to calculate a second point on this plane that the threshold will pass through. And one way of doing this would be, you can see here, it says enter equals J35 into J37. So in this cell here, I'm just going to set this equal to the incremental qualities for treatment B. Okay, and then the question is, okay, what do we need for the incremental costs here? We need to plot a point that would lie on the threshold line. Now the threshold line passes through the origin, and then it's going to pass through the incremental cost that is given by this multiplied by the threshold, right? So I'm going to, in this cell here, I'm going to say equals whatever that incremental cost is multiplied by S underscore threshold here. Okay, and yeah, it likes that, says it's the correct value. And you can see that now we've got 2 points for the threshold. This line has been plotted for us here. We've got our incremental qualities along the bottom. We've got our incremental costs on the vertical axis. The origin is here. That's where treatment A is plotted at the origin, and treatment B is plotted up here. And so treatment B is above the cost effectiveness threshold. And when you are above that threshold on the incremental cost effectiveness plane, it is not cost effective. Okay, so this is not cost effective. You can also see that it's not cost effective in 2 other ways. One is by looking at the incremental net monetary benefit. So negative anything would mean it's not cost effective, given the incremental costs, the incremental qualities, and given the cost effectiveness threshold, which right now is $50,000 per quali, that's resulting in a negative incremental net monetary benefit. The other way of telling that it's not cost effective is to compare this ISA to the threshold. When you have a positive incremental cost and a positive incremental quali, in that case, an ISA that is greater than the cost effectiveness threshold indicates that the technology is not cost effective. Okay, we're willing to pay an additional $50,000 for an additional quali, but we're not willing to pay $86,000 for an additional quali, right? Which is what that ISA is telling us that treatment B costs. So several different ways, looking at the net monetary benefit, looking at the ISA, and looking at the cost effectiveness plane visually, several different ways that we can tell that this treatment is not cost effective at a $50,000 per quali threshold. If we come down, we can see the incremental net monetary benefit break-even curve. So this is a relatively recent figure that was proposed by McCabe and colleagues several years ago. And effectively, this is showing the total incremental net monetary benefit over all possible time horizons from 0 up to 60 cycles. And you see that in that very first cycle, we're already on a negative because treatment B is more expensive than treatment A. And over time, we just incur more and more costs with treatment B. And at $50,000 per quali, it doesn't pay for itself. It is not good value to go with treatment B. This break-even curve just goes further and further down over time. It will eventually plateau. It will eventually sort of level out because eventually everyone will be dead in the model. Okay, so step 8.3 says, consider the impact of a higher cost effectiveness threshold. So we need to go to the settings sheet. And do you know what I'm going to do? I'm going to just scroll so you can see on the right, you can see the table at the top, you can see the plane, you can see the break-even curve. And then on the left, I am going to switch to the settings sheet and I'm going to change it to $100,000 per quali and then wait a few seconds for it to recalculate. And the questions that we need to answer are, have the incremental costs, incremental qualities and ISA changed? What about the incremental net monetary benefit? There's a few others. We'll come back to these questions in a moment. So we go to settings, we change that to 100,000. I'm going to go back to the instructions. You can see immediately that there's been a couple of changes here. And what are the questions? So have this, the incremental costs, the incremental qualities, and the ISA, have they changed? Have a think about that. Have they changed? Was it 86,000 before? Yeah, I think it was. These have not changed. These are exactly the same. So changing the threshold does not change the incremental costs, incremental qualities, and the ISA. But what about the incremental net monetary benefit? That was negative before. And raising our willingness to pay threshold now makes it positive. So treatment B is now cost effective. And again, you can see that in three different ways. Treatment B is cost effective because the incremental net monetary benefit is now positive. It's cost effective because the ISA is now below the threshold, right? And just to be clear, because the incremental costs are positive, the incremental qualities are positive, we need to interpret the ISA by, if it's lower than our threshold, then it's cost effective. And if it's higher than the threshold, it's not. The reason I keep clarifying this is that if these were negative, then you would interpret the ISA in the opposite way. Okay, but that's beyond the scope of this exercise. So it's cost effective because the ISA is below the threshold. It's cost effective because the incremental net monetary benefit is positive. And it's cost effective because if you look at the visual, cost effectiveness plane, you can see that point B is now plotted below the threshold line, right? So three distinct ways of seeing that it's cost effective. We can also look at this incremental net monetary break-even curve. So do you remember before it just got more and more negative? Well, now that we have a higher threshold, it starts off negative, but eventually treatment B pays for itself. At about 40 cycles, so about 40 months, the incremental net monetary benefit gets to 0. So that's the cumulative incremental net monetary benefit gets to 0. And then beyond 40 months, it's positive. So treatment B is cost effective if your time horizon is 40 months or more. So at 60 months, yeah, it's cost effective. If we reduced it to 50 months, yeah, cost effective. 40 months, yeah, it just is. But if we reduce the time horizon to 30 months, well then no, that's not cost effective. Given all of the assumptions, parameters in our model, it takes about 40 months for treatment B to pay for itself. So this is a really, really useful figure for a decision maker wanting to know how long will it take for this investment to actually pay for itself. And of course, if the decision maker wanted a return on their investment, right, not just breaking even, but they actually wanted a positive return on their investment, well, then it's going to take a little bit longer, right? So we've answered these questions. On the incremental cost effectiveness plane, the marker for treatment B is now below the threshold line. And the interpretation is it's now cost effective. It wasn't before. And then take a look at the break-even curve, and it takes about 40 months for it to be considered cost effective. And we can look at the numbers on the cumulative incremental net monetary benefit sheet. You can see that they now become positive. And to be clear, they come positive at exactly 40, after 40 cycles. Yeah. Okay. So when we're ready, tick the checkbox. Okay, so that's 8.3 complete. 8.4, we're going to consider the impact of a shorter time horizon. So we've already considered doing a scenario analysis on the threshold. Now let's consider the time horizon. So we're going to go back to the settings sheet and change the time horizon to 3 years. That's 36 cycles. So again, what I'm going to do is make it so you can see everything here. And then I'm going to go to the settings sheet on the left and change this to 36 cycles. Okay, so what happened? First of all, it's saying, has your summary table changed? Why might the ISA update following a change in the time horizon, but not following a change in the threshold? So you remember on the previous step, we changed the threshold and the incremental cost, the incremental qualies, the ISA, they didn't change previously because we just updated the threshold, right? Well, now we've changed the time horizon, and that does impact upon the incremental costs, incremental qualies, and the ISA. Is treatment B still considered cost effective? Well, our threshold right now is 100,000. Remember, we raised it to 100,000. So, but the ISA is now slightly above 100,000. So actually now with this shorter time horizon, no, it's not cost effective. And that is again reflected in a few different ways. The ISA is above the threshold. The incremental net monetary benefit is now negative. And visually, we're plotting treatment B above the cost effectiveness plane. So 3 different ways in which you can see that treatment B is no longer cost effective with this higher threshold, but with this shorter time horizon. Why is treatment B plotted near to the threshold on the cost effectiveness plane? Why is it so close? It's almost touching the threshold. And that's because the ISA is very, very close to the threshold, right? And equivalently, the net monetary benefit, the incremental net monetary benefit is very, very close to 0. Right? Where that is 0, exactly 0, this would be exactly equal to the threshold, and this would be plotted exactly on the threshold. And finally, has the incremental net monetary benefit break-even curve updated following the change in time horizon? If not, why not? So no, this is exactly the same as it was in the previous step. It changed when we updated the threshold, but not when we updated the time horizon. And the reason being that in calculating this curve on the cumulative incremental net monetary benefit sheet, when we calculated the values that get plotted here, we don't take into account the time horizon. This already factors in the time horizon, right? Because it's cumulative over these different cycle lengths, over these different time horizons, right? So changing the time horizon does not update this. Instead, the way we'd interpret this is, well, at 36 months, we are now about here, and look, it's negative, right? So it's not cost effective. So we could actually have predicted what we just saw up here, that it's going to become not cost effective. We could have predicted that prior to changing the time horizon. 36 months is not quite enough for treatment B to have paid for itself. Okay, let's tick the box to continue. Okay, so we now return the settings to the default values. So we will go to the settings sheet here, and it was previously 60 cycles and previously $50,000 per quali. And you can see that these figures have returned to how they used to be. Treatment B is not cost effective over any cycle length, over any time horizon, I should say. Okay, let's go back to instructions. And this is the end of part 1 of the exercise. And if you wish, you can build this model in R. The deterministic model is complete. And R is an alternative way of building models. So there's capabilities that you can do in R that you cannot do easily, at least in a spreadsheet package. Where you have a very complicated model, it becomes much faster to build and much faster to execute if you build it in R. So there are a number of advantages to using R over using a spreadsheet package. I think for learning how to build these models, I think there are advantages to using a spreadsheet package. But the next step is to build it in R. So that's why I like to teach spreadsheets first and then build upon that by building the model in R. So if you wish, you can go and have a go at trying to build this model in R, and there are various resources available for doing that. But when you're ready, tick the box to the right to start part 2. Okay, and that brings us to the end of part 1. And in the next video, we will start part 2, where we make this model probabilistic.